Lesson 6-7, Solving Equations and Inequalities. And in this lesson, you learn to solve equations and inequalities containing rational numbers. Why is it important? Because inequalities can be used to find the minimum number of signatures needed for a petition. Let's take a look at this real-world application in music. Whether it's rock and roll, jazz, rap, or classical, the art of making music is the same. About 2,600 years ago, Pythagoras discovered the mathematical principles behind the musical scale. Musical sounds are made by vibrations. He discovered the relationship between the vibrations and the notes of a scale. So this is the relationship. If n represents the vibrations for do or middle C, the vibrations for the other notes going up the scale are given below. Do is n, are represented by the n. Re is 9/8 of n. Mi is 5/4 of n. Fa is 4/3 of n. So is 3/2 of n. La is 5/3 of n. Ti is 15/8 of n. And Do, one octave above, will be 2/1 of n. Okay, knowing that scale, let's say a guitar string vibrates 352 times per second to produce Fa. Find the number of vibrations per second needed to produce middle C. So if it takes 352 times per second to produce Fa, how many vibrations will it need to produce middle C or Do? Okay, so what you learned about solving equations with integers can be used to solve equations with rational numbers. Again, just like any word problem, we start with a let statement. Let n represent vibrations for middle C, okay, and vibrations for Fa is, okay, 4/3 n equals 52 because there are 52 vibrations for a guitar string, okay. So that will be our equation, and we want to solve for the variable n. Remember, in this type of equation, we need to isolate n. That means we need to undo 4/3. And in order to undo 4/3, we need to multiply both sides by its reciprocal, the reciprocal of 4/3, or the multiplicative inverse of 4/3. Okay, again, going back, before we do that, we need to isolate n. When we say isolate n, n should be isolated on the left side of the variable, where its only coefficient would be, okay, 1. But remember, 1 is never written. So when you're isolating n, we want to undo everything else that's next to n. Okay, so we want to isolate n. So in this case, we multiply both sides by the reciprocal of 4/3 to make 4/3 1. To make the coefficient of n 1. So we multiply both sides by 3/4, the reciprocal of 4/3. Remember, it's an equation, so whatever you do to one side, you need to do to the other side. And then n is now isolated. We now have n is equal to 264. Okay, so the guitar vibrates 264 times a second to produce middle C or Do. Okay, let's take a look at example number 1. Is it below? Nope, it's on the next slide. So example number 1, solve each equation, solve and check your solution. We have 6.5y equals negative 63.7. Again, we want to isolate the variable y, so therefore we need to divide both sides by 6.5y to make the coefficient of y 1. Okay, if you don't remember what the word coefficient means, it means coefficient is the number before the variable. Okay, so divide both sides by 6.5. Okay, negative 63.7 divided by 6.5. Remember, when you divide the negative by a positive, it will always be a negative. So y equals negative 9.8. Okay, checking our answer, we simply substitute the value of y to our original equation, okay, which is 6.5y equals negative 63.7. Then we get 6.5 times negative 9.8, Okay, is it equal to negative 63.7, replacing y with negative 9.8. Now we find that they're equal and our answer checks out. Okay, let's take a look at B. Negative y over 5.3 equals 8.9. Okay, remember that negative y over 5.3 is a division operation. That means we need to undo negative 5.3. We undo negative 5.3. Since it's division, we multiply both sides by negative 5.3. Okay, so that the coefficient of our y will be equal to 1. So multiplying both sides by negative 5.3, a negative times a positive will always be a negative. So y equals, okay, negative 47.17. Okay, again, we forgot that we need to estimate right here. Oops. Oh, didn't say. So then never mind. So the estimate should be around negative 45. Our answer is close enough. So we're good to go. Okay. Finally, letter C, 7/9 k equals negative 5 over 12. Okay, we want to isolate k again. That means we need to undo 7 over 9. And we undo 7 over 9 by multiplying it by its reciprocal, which is 9 over 7. Okay. So since it's an equation, whatever you do to one side, you need to do to the other side. So multiply both sides with 9 over 7. And k equals negative 15 over 28. A negative times a positive will give you a negative. Okay. Checking our answer, we simply substitute negative 15 over 28 to our original equation. And then we get negative 5 over 12 is equal to negative 5 over 12. And our answer checks out. Okay, let's take a look at example number 2. You can use the same skills you developed to solve inequalities with integers to solve inequalities with rational numbers. So we want to solve this inequality, t over 4.3 is greater than or equal to 5. Again, just like an equation, we need to isolate the variable t. And since this is a division operation, we need to undo 4.3. And in undoing division, we need to multiply. So we need to multiply both sides by 4.3 to make the coefficient of our t equal to 1. So now we have isolated the variable t is greater than or equal to 21.5. So any number greater than or equal to 21.5 will be a solution to this inequality. Okay, and then we graph our equation, our inequality. Remember, it's a greater than or equal sign, greater than or equal to sign. So it's a closed dot. Since it's pointing away from the variable, the arrow goes to the right. Okay, and checking our solution, we need to find a value that is of t which is greater than or equal to 21.5. Let's try 25, a number that is greater than 21.5. Okay, so substitute the number 25 to the variable t. Okay, 25 over 4.3, is it greater than or equal to 5? The answer is yes, it is, because 5.8 is greater than or equal to 5. Our answer checks out. Example B, you have negative 2/3 b is greater than negative 9 1/2. Okay, so first we want to isolate b and we want to make its coefficient equal to 1, so we need to multiply both sides by the reciprocal of negative 2/3, which is negative 3 over 2. Okay, and remember, in inequalities, when you multiply both sides with a negative number, okay, the inequality switches. So from a greater than sign, it switches to a less than sign. Okay, so now we have b will be less than or equal to, multiply it straight because there's no GCF. A negative times a negative gives you a positive. Negative 57 over 4, or 14 1/4. So b is less than 14 1/4. Okay, and any number less than 14 1/4 will be a solution to this inequality. Okay, and let's take a look at the last example. Before we go to the last example, the key word that you need to remember, or the secret word that you need to remember, would be the word coefficient. Please spell it correctly. The word is coefficient. Okay, example number 3. A replica of the Globe Theatre, where Shakespeare's plays were originally performed, is currently being constructed in London, England. Supporters of the project have raised almost $13 million, which is over 4/5 of the budget. How much is the budget? Okay, so we write an equation. Let B represent the budget because that's what the problem is asking for. Okay, so what do we know? We know that 13 million, okay, is over, which means an inequality of greater than 4/5 of the budget. When you say 4/5 of the budget, it's 4/5 B. Also remember that when you talk about the word of in math, it always represents multiplication. So when you see the word of in math, it always represents multiplication. Okay? So 13 million is over 4/5 of the budget, or 13 is greater than 4/5 B. Okay, so we have our inequality. Okay, and then we want to solve for B. That means we need to undo 4/5 by multiplying each side by its reciprocal, 5/4. Okay, and then we have 65/4 is greater than B, or B is less than 65/4. So that means the budget is less than 65/4, or $16.25 million. If you notice, the inequality did not reverse. The symbol of the inequality did not reverse simply because we multiplied both sides by a positive number. Alrighty, that's the end of the lesson. Thank you for watching.